Hey guys, let's try this next problem. An environmental group conducted a study to determine if crows in a certain region were ingesting an unhealthy amount of lead. A random sample of 24 crows ingested an average of 4.9 parts per million with a standard deviation of 1.12 parts per million of this lead. So let's just jot that down. N equals 24. X bar is equal to 4.9. And once again, this is S because the 1.12 comes from the 24, which is a random sample. So this is a sampling standard deviation. Also, one other great hint, I mean, I don't want you to use this, but typically when these are small amounts, when N is small, we tend to go for a T. So a stem plot shows no unusual pattern. Excuse me, that arrow should be right here. Shows no unusual patterns, okay? Otherwise, we can't do it if it shows unusual patterns. Remember that a T and a Z needs to be approximately normal or normal in order for us to proceed, okay? So that should say no unusual pattern or outliers. So it's safe to assume that the distribution is approximately normal. So construct a 90% confidence interval for the mean lead level of crows in this region. Okay, so step one. Step one is our conditions. So I'm just going to save us some time. You guys will write perfectly. You'll say the stem of the problem states both, states that the crows were chosen at random. Crows were randomly selected. And it also states the distribution is approximately normal, okay? Distribution is approximately normal, so it's okay to proceed. So, okay to proceed. Now, step two is our formula. Remember, this has to do with averages. Average, okay? So averages, you go to your formula sheet, and it's only one sample. Notice there's only N equals 24. It's only one sample. So with that being said, and we know it's a confidence interval, and it's a 90% confidence interval. So we go to one sample, confidence interval, statistic plus or minus critical value times the standard deviation of the statistic. If you want to be really great about this, you put 0.90, comma, 23 for the degrees of freedom, right? Degrees of freedom is equal to N minus 1, so the degrees of freedom is 23. We got to plug in some numbers. So we got 4.9 plus or minus this magical number that we're going to get through our calculator. I hope you guys saw the video right before this. And square root of 24. So how do we get this number here? Let me switch pens, let me switch highlighters, and take a look at the next slide. We go to second, we go to distribution, you end up here, and then you go to inverse T. Once we go to inverse T, you're going to have an area and the degrees of freedom. Our degrees of freedom we said was 23 in this case. How do we get this area to be 0.05? Well, the question asks for a 90% confidence interval. Once that happens, we have 5% left on each side. This area is asking for this piece right here. So you're going to get a negative. That's okay. Like I said in the past video, we're gonna really ignore that sign because it's going to be plus or minus. So negative 1.714. Negative 1.714 goes in there. Great. Once we do that, we're going to have to come here. Okay. Once you set it all up, you're going to press stat by itself. It's going to get you to test. After you go to test, you go to number 8. Remember that 1 through 6 is only for hypothesis tests. Everything else will be intervals. You plug in your data, 4.9, 1.12, 24, and then 0.9, calculate. You get this here. So what does this mean? Well, based on the sample, okay, on these samples, actually, based on these samples, we are 90% confident that the true mean, okay, the true mean is, if you end up putting this in your part 2, you could say that the true mean lies in the interval above, or you could say that the true mean is the true mean lead that the scarecrows, you got to be very specific, that the true mean lead that the scarecrows ingest, or the crows, I don't know why I said scarecrow, but we're off to see the wizard, that the crows ingest is between this number and this number, okay? So 3 steps, then you're done. So we think that it's between 4.5 and 5.2 parts per million, and that's all. So we had step 1 is going to be this guy, but don't go anywhere because I have a second part to this. Step 1 will be this guy. Step 1 will be conditions. Step 2 would be formula. Step 3 will be interpretation. And then, this is what my answer is, but I want to talk to you about this part right here. A mean lead greater than 6.0 is considered to be very unhealthy. Do we have reason to think that the crows are ingesting a healthy amount of lead? Well, you just say, no, since 6.0 does not lie in the interval of plausible values, we do not think, I know that's 2 words, okay, we do not think that they are ingesting unhealthy amounts of lead. And if you want to be really good, I mean insanely good, you say at the alpha equals 0.10, because this is a confidence interval that's 90%, so we have 10% left over. So that's how we do this problem. I hope you guys remember it, enjoy it. Take your time, pause the video, take this all in, ingest it. Take care.